Okay, this is the M1 paper from October 2023. It's question number 4, and as we can see, this is a vectors question, but we're going to be combining vectors with SUVAT in order to be able to work out the answers to this question, a little bit of kinematics work. So let's have a look at what we've got. It says particle moves with a constant acceleration minus lambda I plus 2 lambda j, so that's my acceleration. It says at time t equals 0, the velocity is 5i minus 8j, so that's going to be u. And then it says, can we find the velocity, v, when t equals 5 seconds, and give everything in terms of i's, j's, and lambdas. So yeah, absolutely. Let's just set out our SUVAT and see what we've got. So S isn't involved in the question at all at the moment. They told me that the initial speed or velocity was 5i minus 8j. Final velocity is what I'm trying to find. They told me the acceleration was minus lambda I plus 2 lambda j. And they said, can we find the velocity after 5 seconds? So V, U, A, and T there is our classic SUVAT equation. V equals U plus AT. Just substitute everything in. V is going to be equal to, so that's 5i minus 8j plus minus lambda I plus 2 lambda j multiplied by 5. So tidying that up, that's the answer, but let's tidy it up and put it all together in terms of how many i's, 5 minus 5 lambda i's, and how many j's, 10 lambda minus 8 j. So that's an expression for the velocity. It then says the speed when t equals 5 is 13. So the speed is the magnitude of the velocity. And if that's equal to 13, can we show that quadratic? Yeah, so I pretty much know what I'm going to be doing for that part. We would say speed, which is the magnitude of the velocity, is equal to 13. And it's also equal then, if it's the magnitude of this vector, to the square root of 5 minus 5 lambda squared plus 10 lambda minus 8 squared. So if we square both sides, 169 is equal to 5 minus 5 lambda squared plus 10 lambda minus 8 squared. So 169 is equal to, you can take as much time as you want over this. I've said in all my videos, I know how to do a minus b squared. It's a squared, 2ab, b squared. So I use that quite often. So in this case, this is 25, it's minus 50 lambda, and it's plus 25 lambda squared. And then the same for the other one, that's going to be 100 lambda squared. It's going to be minus 160 lambda and plus 64 there. Take your time in tidying this up simply because it's a proof, isn't it? So that's, what have we got there? 125 lambda squared. We've got minus 210 lambda, and we've got plus 89. That's all equal to 169. So that's going to make 125 lambda squared minus 210 lambda minus 80 equals 0. And what we're trying to get it to, yeah, just divide everything by 5 by the looks of things. So divide everything by 5 will give me what we were trying to do. So 25 lambda squared minus 42 lambda minus 16 equals 0. So part B sorted out. Part C then says, can we find the direction of motion of P when t is equal to 4, giving our answer as a bearing corrected to the nearest degree. So first thing I've got to do is to actually work out what lambda is, so I can work out what the velocity was. Let's do that first of all before we do anything else. The reason I'm hesitating there is this 25 lambda squared minus 42 lambda minus 16. If you look in the official answer schemes, it factorizes it. I don't know that I'd be able to factorize. I think I'd probably just stick it into the quadratic formula. I'm going to show you what happens if you do factorize. You get 25 plus lambda and lambda minus 2 equals 0. I don't know how quickly I'd be able to do that compared to put it into quadratic formula, 42 plus or minus the square root of 42 squared and 4, 16, 25, all divided by whatever. But here we get lambda works out to be equal to minus 8 over 25, or lambda works out to be equal to 2. Does it say anything about lambda? Yeah, lambda is a positive constant there. So we know lambda is equal to 2. And so if lambda is equal to 2, that means I can now work out what the acceleration was. So if lambda is equal to 2, the acceleration then is minus 2i plus 4j. So let's go back and just check and see what they actually wanted then. Now that I've got that acceleration, they said find the direction of motion when t equals 4. So I've got to find a new velocity, a velocity when t equals 4. Once I've got that velocity, I can worry about the direction of motion. They want it as a bearing to the nearest degree. Okay, so another quick bit of SUVAT here then. S, U, V, A and T. Again, we've not been interested in S throughout the whole of this question. But we knew it started off with U was 5i minus 8j from the original question. We know that t is equal to 4 this time. And we've got our acceleration now being that constant acceleration all the way through. So that means I can find V again, bit repetitive this question. V equals U plus AT again. So V is going to be 5i minus 8j, 4 lots of minus 2i plus 4j. So that all tidies up to be minus 3i plus 8j. And we now want to know what bearing that's heading on. Always do a quick sketch, just make sure you're in the right quadrant here. If it's minus 3i plus 8j, that's going to look like this, isn't it? So it's not to scale, but it's close enough that this is minus 3i and this is 8j here. So the bearing will actually be all of that angle all the way around there. But what I'm going to do to start off with is just work out what theta is, because I can do that really quickly using SOHCAHTOA. So tan theta is equal to opposite over adjacent. So theta works out to be 69.44 degrees. So the bearing then is 270 plus that 69, works out to be 339 degrees. The bearing is, that angle all the way around there. That would be the bearing. What does it ask us for? It says giving the bearing to the nearest degree. So yeah, I've done that, finished that question. Right, yeah, another interesting question. Hopefully that will make sense to you once you've read it through a couple of times.